I think we'll get started. So thank you so much for joining this morning, everyone. I really appreciate you being part of the webinar with us. My name is Heather Galt, and I'm one of the members of the PPO team. I'll be your host for today. And before we get started, I thought it would be helpful just to go through a couple of little housekeeping items to make sure that we have the best webinar experience possible. So first of all, down the bottom of your screen, if you're not familiar with webinars on Zoom, you'll notice a couple of different options to connect with us during the webinar. One is there's a Q&A button, which is down at the bottom of your screen in the middle, if you're on a computer, that is, and likely on the bottom of your screen also if you're on a phone or an iPad or a tablet. So if you click that button, that will pull up a panel to ask questions of our panelists. We'll have a Q&A session at the end, so those questions we'll hold on to until after the presentations have happened, and we'll answer those questions at that time. The Q&A is only visible to members of the panel, so that's Tim, Jamie, and myself. But if you would like to chat with everyone who's participating in the webinar, you can use the chat button also down at the bottom and a couple of icons over from the Q&A. So feel free, just be aware if you're using the chat that will be visible to everyone on the webinar, where the Q&A will be visible to the panelists. We are recording today's session, so if you're looking to share it with a member of your team or with someone else that you know who might be interested, we'll be sharing a link to the webinar tomorrow once that is uploaded into the cloud. I will ask you to just go on mute if you haven't already. Put yourself on mute so that we are able to hear the panelists without any interruptions. And if you have a question later and would like to be brought in to chat with one of the members of the panel, happy to do that during the Q&A session. As with all of our other webinars, we will be posting this onto the PPO blog as of tomorrow when it's available. So feel free to check it out there. You can find all of our resources on our website and in our blog at ppo.ca/resources. So before we get started, I'd like to introduce our two speakers today. You can see them both on this screen. We'll be starting with Tim Stork, who is our Senior Solutions Engineer here at PPO. Tim's been with the company for about 8 years in a variety of roles, and he's an expert in how our technology works and how it operates in line in a meat processing facility. So welcome, Tim. And I'd also like to introduce Jamie. Jamie Poholko is our Customer Success Manager at PPO. He's been with us for about 2 years and works with some of our very largest clients in making sure that they get the most value out of the system as it operates in line at their facility. Jamie brings us about 20 years of experience in a number of different industries and has been a massive asset to many of our customers and also to the PPO team. So welcome, Jamie. So for today, we're going to start with Tim, as I mentioned earlier, and Tim will be talking through an introduction to hyperspectral imaging, which is the technology that PPO uses, and talking about how PPO Smart Imaging System operates in the plant. Jamie will then talk a little bit about some customer case studies. You'll know, I'm sure that these case studies will not have names on them, but we'll be talking sort of about some generalities of experiences that we have had in different facilities and how we've delivered return on investment to our various clients in the meat industry. And with that, I will turn it over to Tim. We'll get this thing started. Thanks so much.
Great. Thanks for that introduction, Heather. Today, I'll be talking about PPO Smart Imaging and why it's a unique solution in the meat industry. Some of the topics I'll cover include a review of some of the biggest industry challenges today, a description of PPO's Smart Imaging solution capabilities and the value they bring, and a dive into how the solution works. We constantly hear from our partners in the meat industry about the ways that your business is being squeezed. Safety costs are rising, consumers want transparency on the health and safety of food products, labor turnover is very high and it's hard to find good people and keep them, and margins are being eroded by high material costs and processing errors. The PPO Smart Imaging solution helps to address these challenges in a number of ways. Improving food safety by finding and eliminating a wide variety of foreign materials, maximizing throughput by reducing downtime and eliminating product waste, and optimizing yield by enabling tighter process controls and automated least cost formulation. All of these things lead to better margins for our partners. Jumping into the capabilities of our solution, foreign material detection is PPO's first and most prevalent application. Let's start by looking at some of the other methods used to find foreign materials today. You have people. Manual inspectors have the ability to find very small foreign objects, but their attention drifts over time. People are not designed to pay close attention to the same task for hours. Vision systems, also known as color cameras, only find things if there's a strong contrast with the background. This makes it difficult for vision systems to find foreign materials that are the same colors as meat products, like wood, cardboard, white plastics, and bone. X-rays and metal detectors can see inside products, but only find very specific materials. X-rays are great at finding high-density materials, and metal detectors can find ferrous metal objects. But these technologies miss a broad range of low-density materials. PPO's unique solution is an automated inline surface scanning method that finds foreign materials regardless of color and density. PPO detects a wide variety of foreign materials that others can't. Here are some examples. Wood, usually from pallets, cardboard and other paper products like labels, hard plastics like interlocking conveyors, guarding, combo bins, plastic tools, and this includes a variety of types of plastic like polyethylene, polypropylene, acetyl, and others. Soft plastics like liners, aprons, and flexible continuous conveyor belts. Rubbers, these are your gaskets, O-rings, and sealant materials. Natural fabrics like cotton gloves. Different types of personal protective equipment like rubber gloves and earplugs, and even materials that occur naturally in product like bone. No other technology can detect as many different types of foreign materials as PPO's Smart Imaging solution. One of our customers ran a side-by-side performance comparison in their plant on an X-ray, vision system, and PPO Smart Imaging System. This test included a wide variety of foreign materials and tested all equipment under the same conditions. As you can see here, the X-ray was great at finding dense materials like metal and glass, and the vision system found brightly colored materials with high contrast. But only PPO Smart Imaging found a wide variety of foreign materials regardless of color and density. This foreign material detection delivers big value for our customers, whether they're a primary harvest facility or doing secondary processing. By removing foreign materials from the product stream, PPO enables our partners to throw away less contaminated product, reduce downtime spent cleaning contaminated equipment, and save time and money by preventing equipment damage from hard foreign materials. Our solution also lets you control chargebacks. Whether you're a primary producer and you want to prevent chargebacks, or a secondary producer trying to track your vendors, PPO's solution lets you take control. And finally, when it comes to foreign material detection, we can help protect your brand. The next application that I'm going to talk about is lean point measurement. We hear from our customers about how important it is to accurately measure the amount of fat and lean in your process. There are a number of different methods used today. Historically, lean point was graded by highly experienced operators based on how the product looks and feels. Using decades of experience, people are able to estimate this composition pretty accurately. But this method depends on a stable labor force to develop long-term expertise. With high turnover, it's impossible to train new experts. It's better to rely on objective measurements that ensure repeatability. Offline lab tests are the most common method used today. A smaller sample is taken from a production batch and tested in the lab using NIR or chemical analysis. The drawbacks of this method are that the small sample may not be representative of the larger product batch, and there's a significant delay from when the sample is taken to when the test is complete. This delay limits the ability for real-time process adjustments. There are also some inline systems that are able to measure composition of the entire product feed in real time. One example of this technology is X-ray, which measures the amount of fat based on density. The drawback of this technology is that because it only uses density information, it indirectly calculates the lean component and assumes the protein and water content based on historical averages. Having an accurate measurement of protein and water content is critical for certain product formulations. PPO solutions also deliver live inline analysis of the full product stream with high accuracy. And we're capable of directly measuring fat, moisture, and protein content. This solution can also run simultaneously with foreign material detection without sacrificing performance. This application provides value to our customers by enabling tighter control of product formulation and providing live feedback for process control. This lets our partners reduce their material costs and improve product quality. PPO's technology is also capable of measuring many other important metrics in parallel. These include physical specifications like size and shape, and meat quality attributes like tenderness, marbling, color, texture, detection of myopathies like woody chicken and PSC in pork, and other product metrics like water activity in shelf-stable, ready-to-eat products. PPO Smart Imaging is unique in its ability to do so many applications with one system without compromise. Next, let's talk about the components that make up the Smart Imaging solution. These components work together to maximize capability and value. We have an optical component, equipment, software, data, and analysis. What makes PPO unique is that we're not just an optics company or an equipment manufacturer. We have deep expertise across all these areas. This is what makes PPO solutions so capable. PPO is an experienced, proven partner that adds multi-dimensional value to our customers' business. Let's start by talking about the optical system. PPO uses a unique technology called hyperspectral imaging. The word hyperspectral refers to the fact that we look at hundreds of specific wavelength bands of light. This works by illuminating the product with a broad spectrum light, capturing the reflected light and breaking it into its different wavelengths. When the light interacts with the product, wavelengths are reflected and absorbed differently based on the chemical composition of the sample. This is what allows us to find foreign materials regardless of color and density. You may have heard other companies call their systems hyperspectral. In reality, these systems have a limited number of wavelength bands and fall into the category of multispectral imaging. Because they have fewer wavelength bands, multispectral systems have a more limited range of capabilities and less flexibility to adapt over time. PPO is the only true hyperspectral system for the meat processing industry. In addition to PPO's proven hyperspectral imaging, we also include a high-quality color vision camera to get the best of both worlds. The NIR hyperspectral data provides the capability to see information about chemical composition by looking at over 500 discrete wavelengths of light. On the other hand, the vision system is a complementary technology that provides high-speed, high-resolution images with high-quality color measurement. By combining the data from both of these cameras, PPO Smart Imaging multiplies the capabilities of the solution. Moving on to hardware, here are two images of different configurations of PPO's Smart Imaging system. No matter the configuration, the Smart Imaging system is an integrated solution. It doesn't just scan product, it also does product handling, flipping to see multiple sides, and rejection of unwanted material. Because we all know it's not enough to just see a foreign material, you have to remove it from the product stream. Here are some examples of images taken by our systems in the field. The Smart Imaging system works on a wide variety of different product types. Different proteins like chicken, pork, beef, and turkey, different formats of product like trims, whole muscle, and ground products, and different states, fresh and frozen, raw, cooked, and ready-to-eat products. PPO takes pride in how easy it is to own, operate, and maintain a smart imaging system. We get positive feedback all the time from our customers about the intuitive controls, designed for sanitation and maintenance, and outstanding customer support. And of course, this system is designed for the meat industry. It exceeds all washdown standards. It has proven its ruggedness in factories across North America. Next, I'll talk about data and analysis, specifically the decisions that are made on board the system in real time. The smart imaging system collects rich spectral information on all products going by, and it takes some advanced methods to analyze this data and make live decisions. PPO uses machine learning analysis to look for subtle spectral differences that are beyond the ability of manual analytics. Only machine learning can unlock the full potential of the data. PPO trains different machine learning models for each application, and these applications can operate simultaneously without sacrificing performance. Here's an example of how a smart imaging solution can help to future-proof your plant. Here are 5 identical images of a pork chop. We can look at the same data in many different ways using different machine learning models. Here you can see we use one machine learning model to look for bone, another model to measure fat and protein content, and more models to look for different types of foreign material. Machine learning allows the system to analyze the data for all of these metrics simultaneously. This ability to layer machine learning models creates a very flexible solution. Once you invest in the equipment, the solution can adapt and grow based on the changing needs of the plant. The value of the solution grows with your business. Now I'll hand it over to Jamie to talk about some of our customer case studies.
Thank you, Tim. So I'm going to talk a little bit about the case studies as Tim mentioned and Heather mentioned earlier. I'm going to show you some images of in-plant findings, how we use that data and all that information to help inform your process. And we're going to talk a little bit about return on investment. Foreign material, as Tim mentioned, is our most mature application. So we're going to look at some case studies specifically around those. In this instance, in this customer case study, we are at a secondary poultry processor. So they're bringing in products from other facilities, including their own. They needed a solution to help find some of the things that their other historical and classic X-ray and metal detectors were unable to find: rubber, bone, plastics, and those of the like. They do inspection of many different materials: whole muscle breast, wings, trim, and our machine has paid for itself inside of 6 months. Foreign material findings of blue plastic, wood, cardboard on a daily basis. This is an image from that system. Can you find the piece of wood that our machine found? It's on the left-hand side. Let's zoom in a little bit and see this little piece of Shep pallet that the machine found quickly and rejected and moved out of the product stream, preventing further condemns in their process and making sure it doesn't get into their formed products. Another one of our customers is a major pork processor. They had a corporate initiative to improve foreign material detection and contamination inside of all of their products. And they needed, again, another solution to find things that no other detection technology can find: cardboard, wood, plastics, etc. This customer, after installing our machine, has had 0 foreign material downstream fines? 0. Imagine how your operation could benefit from that kind of result. And the system has paid for itself in less than 15 months, reducing condemns, preventing recalls, and they were able to redeploy one person to higher value tasks. So improving margin and labor. These are some examples of the foreign materials found at this customer facility that they took and sent it to us. Again, 0 foreign materials in their downstream process and 0 condemns directly from the plant FSQA manager. We're currently in progress right now in commissioning in a ready-to-eat operation. This company, like many of our other partners and customers, are looking to put in a solution to find those very difficult things to find that no other detection technology can find well at small sizes. Conveyor plastics, cardboard, and wood. They supply a national retailer, and they were getting foreign material complaints from their consumers, which kind of started this process. So before we were done commissioning, we found upwards of 30 foreign materials in the sizes of 2 to 3 millimeters of plastic while in that commissioning phase. Here's an example of their product going through the production line and the foreign material that's 2 millimeters by 3 millimeters in size, removed out of their process and not getting out to the consumers, reducing foreign material complaints. Like Tim had mentioned, we're in many different aspects of meat processing. So we saw ready to eat, we've seen secondary process, we've also seen a frozen product as well. We're at a harvest plant down in Texas, and this company wanted, again, to find things that no other detection technology can find. Plastics, cardboard. This is a harvest plant. And what we found by using data that came out of our system was that they had a lot of bone going out to their customer. And what we were able to determine based on the information coming out of our system, that there was a maintenance issue with their deboning line. So as you can see in the data on the left, that every time they did a maintenance, it drops down dramatically, and then it would spike up, kind of creeping up over time. So they've adjusted their maintenance schedule on their deboning line, reducing chargebacks and improving the quality of their product going out to their customer. Here's an example of one of those pieces of bone that was found by our machine, and a live photo of it in the plant. So that piece of bone is about 3 millimeters by 5 millimeters. So I talked about that data just a few moments ago and how we can utilize it to make decisions in our plants. So we track decisions and results in real time, and we upload this directly to the cloud. So anybody in the plant can have access to it. You can access it from a corporate office. You can access it from your plant tablets that you have right on the floor. And it allows you to see the rejections and detections by the machine, and then you can aggregate that data. So when you have multiple machines in your plant, you can see which lines are producing which kind of foreign materials, and then diagnose where that's coming from. So this is optimizing yield and cost, because we can look at trends of issues, and you can, as Tim mentioned earlier, you can tie that back to suppliers as well. So return on investment. These are kind of the big things that we all kind of use to understand what are we going to invest in, and how am I going to get my money back? Labor savings, Yes, one of our customers has deployed one person, other customers, a couple of people. Reduction in food waste, reducing the number of condemns that are found in the plant. Chargebacks. Tim spoke about this earlier, about chargebacks with regards to reducing the number of bone pieces going out to a customer. And recalls that are prevented. As we all know, those can really, really add up. All of this together improves margin.
Thank you so much, Jamie, and thank you to Tim as well. Hopefully everyone who participated here today had got some new learnings and was able to take away some new ideas for your own facilities. Now we have an opportunity for Q&A. So as I mentioned at the beginning of the call, if you are on a computer screen and you take a look down at the bottom of your Zoom screen, you should see a Q&A button there to ask a question. So if you click on that, it should pop up a little menu for you and you can type your questions into the chat. Those will come just to Jamie, Tim, and myself, and we'll be happy to share them out in the call. So I'll give everyone a couple of minutes to think through their questions and share them through. But in the meantime, I had a couple questions that I thought I might pose to Tim and Jamie just to get the session started. So why don't we start with a question we often get, which is the throughput and what can PPO system handle in the plant?
Yeah, great question, Heather. So the PPO's technology is an optical method of scanning. And for that reason, it's scanning the surfaces and only what's visible to our cameras can be seen. So for that reason, it's really important to spread the product out in a single layer across the belt. And the conveyors in our system are 30 inches wide, and they run pretty quickly at 80 feet per minute. And the amount of product to form a single layer depends on what size of pieces and what state that product's in. So the actual throughput of product through our system will depend on the type of product. Really small product like bacon bits, fine dices and grinds, we can do up to about 20,000 pounds per hour. And as things get bigger, like chicken trim and coarse grinds, we can do up to 30,000 pounds an hour. And then whole muscle things like chicken breasts up to 40,000 pounds per hour, and big trims like pork trim and beef trim up to 50,000 plus pounds per hour, depending on what kind of cuts of meat you're dealing with.
Awesome. Thank you, Tim. Jamie, you talked a little bit about bone detection, and I'm wondering if you could share a little more information, especially given what Tim just shared about how bone detection works in a plant.
Yeah. So as Tim mentioned just a few moments ago, we're a surface technology. So the bone has to be exposed to us in some way. That can be sticking out through the product a little bit, or if a cutting, a deboning machine kind of slices through the bone and there's a little bit of it exposed. That's one of the critical things with our solution, is that it must be visible. We cannot see inside of the product like an X-ray or a metal detector. So if the bone or cartilage pieces are exposed to us, then we have a really good chance of finding them, depending on the size. 1 millimeter sizes are going to be more difficult than 5 and 6 millimeter sizes, as you can imagine.
Awesome. Thank you, Jamie. Okay, we're starting to see some questions come through, so I'll share some of the ones that have come into the Q&A. If I install a system like this, will it replace my metal detector and my X-ray? I can answer that, Tim, if you'd like.
Sure.
Replacement of a metal detector and X-ray is probably a little bit strong. We cannot see inside of the product, like I had just mentioned. So you would lose the ability to see inside of your product. Replacement, I would probably not recommend replacing it, but using it complementary. So a number of our customers use a suite of detection technologies to inspect their product. So our customer that has now had 0 foreign material finds downstream uses a multi-hurdle approach. So they put it through those legacy or those classic technologies before entering our machine, and all 3 of those paired together work extremely well to help reduce any foreign materials getting into your product.
All right, thanks, Jamie. Next question. Does the system summarize and provide the types of foreign materials over a certain period of time?
I can take that one too, Tim, if you want. Yeah. So the system is recording all of these detections as they're happening in real time and exposes that information to you. And you can use that information. So a summary is not a standard part of our solution. It's the raw data, and we have launching in the near future an analytics part of our solution to do just what you're talking about, to summarize and pull together that data so that you can visualize it and quickly action upon it. So there's a second question, I think, in there about routine maintenance.
I was gonna make Jim answer a question and then go back to that one. But why don't you finish off, Jamie? Go ahead.
Sure. So routine maintenance, the system does a calibration every single morning, and after about 8 or 10 hours of operation. Maintenance is a biannual event, in addition to regular inspections. So as sanitation crews are cleaning the machine, some things can break, but there's an inspection checklist at the beginning of every day. So there's not a lot of maintenance on our equipment. We replace the lamps because we're using those that high amount of energy light that's coming in to capture the reflectance, etc. So we got to make sure that those are in an ideal state. So maintenance is around the lamps itself, and then regular machine maintenance that happens inside of a regular plant.
Awesome. Thanks, Jamie. Tim, I'm going to ask you to answer this one. How does it work for items that may be underneath thick product?
Yeah, great question. So when I was talking about our equipment, I alluded to the fact that we have different configurations of hardware, and that we have integrated systems that handle product, but also flip it and do rejection. And the answer to this question is really in that flipping element. So we are surface scanning. We do need to flip the product to see multiple sides. Our 2 different configurations for flipping are what we call our Z configuration, which uses a change of direction to flip it to the other side. It's a little bit hard to envision without an image, but it will fold back on itself through a conveyor transition. Our other method of flipping and jumbling is through our waterfall, where the product falls over a short drop and shows a new surface of the product. So for things you would call thick products, I'm thinking of thick trims and whole chicken breasts. We often use our Z configuration, and we will flip the product to expose the other side and scan it again to find anything on the other side.
Thanks, Tim. And for our American colleagues, since we're Canadian and use the Z, that would be a Z configuration.
Thank you.
We have to go back and check our spelling and check our pronunciation sometimes. So thank you. Anyway, thank you, Tim. That's perfect. So one last question, and Jamie, I think I'll ask you to answer this one. Is lean point technology available right now?
So lean point technology is on the cusp of being available. So we have had a long period of development on that product, and we're excited to partner with any one of you guys in the near term to get that going.
Awesome. And another question has just popped up. Tim, I think I'm going to ask you to answer this one.
Sure.
If you see chemistry, how do you handle product streams with shadows? Do you ignore shadows or see through them because there's no chemistry there to see?
That's a great question. So our systems are optically based, and we need to be capturing light in order to see information. Shadows come in a lot of different levels of intensity. A true shadow would be there's no light getting in there and no light reflecting back. Many shadows actually do have some light coming back. It's just darker than fully illuminated product. So this comes back to how we train our machine learning models. If we're training a foreign material detection application, we need to teach the system what foreign materials look like and what products look like. While we design the robustness of these models, we will also teach it what shadowed foreign materials look like and what shadowed product looks like. And then as we build the model, there will be a limit to how dark a shadow can be and still be able to see inside that shadow. But the system does recognize what a shadow is, if that shadow is acceptable, if it's a foreign material in a shadow, to provide as much value with the information and the data that's there in those shadows.
Awesome. Thanks, Tim. Another great question. Thank you to the audience. These questions are excellent and actually helping us to make sure we cover all the things we were hoping to cover this morning. You mentioned in one of the case studies that the system found a previously unknown problem. How does the system handle something that you didn't know you had? Jamie, do you want to talk a little bit about that one?
Yeah, I kind of see this as two questions kind of wrapped into one. One, the unknown problem in that customer case study was how many bone foreign materials, and this customer saw foreign materials or found bone, as a foreign material, and they wanted to reduce the amount of bone leaving the plant. And they didn't know they had a problem with their upstream equipment. So the system doesn't tell you where to go and look for things. It gives you data, and we need to interpret that data. So to your second part of your question, I'm just going to go back to it here because it's out of my list now. How does the system handle something that you didn't know you had? So I'm gonna answer that with foreign materials. So assuming a new foreign material arrived in your plant because one of your suppliers is using a new type of glove or things like that, we build our system to look for not just certain foreign materials, but for anything that's not really product, that looks kind of like something else. So let's pick cut gloves are made out of Kevlar, but they do not look like pork or chicken or beef. So our system, when it's at the right size, 2-3 millimeters in size, we'll see that very, very easily and very quickly. I hope that answers your question.
And if you have any extended questions beyond that, please throw them back in the chat. Okay, a couple more have come in. How long does it take for a training exercise, or does it depend on the number of foreign material samples provided to the system at one time? Jamie, I'm wondering whether you could answer that and maybe also weave in a little bit about how long it would typically take us to deliver a system.
Yeah, so training of the of your operators and your people is very, very quick. We use industry standard components. The majority of the machine is probably sitting in your plant stockroom right now. We use ABB, Allen Bradley, all those great things. And the delivery of a system from the time of installation is about 6 weeks. So we have to collect a bunch of data about your product in your environment, because frankly, we can't run hundreds of thousands of product in our little shop at PPO. So we need to be in your facility to see the variation, see what it looks like, and come from your suppliers. So that takes a few weeks to do that. And then what we do is we place real live foreign materials right onto the product as part of that commissioning exercise. We do that outside of regular operations, just before a sanitation cycle, et cetera, or in an offline position, so it's not impacting operations. And then about 6 weeks later, we're ready to put the system through its paces, and we do a performance demonstration. So we put form materials directly on product, and we prove to you that it's finding all of those things, just like you do similarly with your other detection technologies.
Awesome. Thank you. I'm going to keep you, you're in the hot seat. So the next question that's come in, how custom is this equipment? Are spare parts and service hard to come by? Could the plant maintenance team work on the equipment if needed?
So I kind of started answering that question a little bit in the previous one. The equipment is custom in that it's ours, and it's made of stainless steel that's bent to look like it is. But as far as components that maintenance teams are exposed to on a regular basis, we're using industry standards. We're using interlocks belt. That's going to be in your plant already. We're also using, like I said, ABB breakers and electrical components, Allen Bradley PLCs, etc. So maintenance teams are able to work on it without question. There are some very sensitive bits. So the optical path. So Tim talked about how we use a tandem approach with our cameras. So we have a hyperspectral camera and we have the visual camera. So there's some sensitive optical bits in there that is only serviceable by PPO. So some of it, the large majority, is serviceable by your maintenance teams, but the sensitive stuff is only serviceable by us.
Awesome. Thank you, Jamie. The questions keep coming. In a multi-hurdle approach, at what stage would your equipment be located? After the metal detector, after the X-ray? Tim, do you want to take that one?
Yeah, absolutely. So this is very much process dependent. We have the one example that Jamie gave before. We are at the end of those three pieces of equipment. But in a lot of facilities, that equipment doesn't need to be all together. They may have a metal detector at the beginning of the process to make sure that metal doesn't come in and damage your processing equipment. They may also need an X-ray at the end of the line on finished product as part of their standard process of inspecting the final product before it gets to the consumer. So we work with our partners to figure out what's best for the process and how to optimize the value of different stages of inspection and where PPO will deliver the most value.
Awesome. All right. Thank you so much. Well, Tim and Jamie, thank you for your presentations today. And thank you everybody so much for joining. Really appreciate your time. If you have questions that we weren't able to cover today on our call, please feel free to reach out to your PPO account manager or representative, or reach out to sales@ppo.ca. And we will be able to share the presentations and the recording with you over the next 24 hours or so. So please watch your email for that follow-up. And I hope everybody has a wonderful day. Thanks so much. Take care.